we're going to work on a theorem from logarithms called the Change of Base Theorem that will help us to be able to simplify logarithms that have bases that are not the very common ones, like the base 10 or base e. So when we have those other bases, our calculators now can usually take care of those, but when we don't have a calculator that can do logarithms with different bases, or when we want to just do it quickly using base 10 or base e logarithms, we use the change of base theorem, and it actually is a pretty miraculous theorem to help us to simplify the work pretty quickly. So the change of base theorem, just so we start off having this, our change of base theorem is if we have log base a of c, what it allows us to do is change the base to log of just the c, so just take the log of c with a common log, and then, but you got to put it over the log of a. So if you take the common log of the c, put it over the common log of the a, change the base to base 10 here, it will give you the same value. Now, what I want you to recognize is it is not limited just base 10. If I did the natural log of c over the natural log of a, it would give me the same answer. So I'll put or this one. That would be ones that would make sense to use because they're right there on your calculator. But also, if you just chose, maybe you have a favorite base for logarithm. Say your favorite base is log base 64. Say you love base 64. Well, it's the same for that one. Change of base theorem works for any base you want to change it to. If you take the log of the number inside the logarithm, log of the base, you'll get the same value. Let me illustrate that with a couple examples here. First of all, this is one that we could do without a calculator. This is asking 3 to what power is equal to 81. So when we do that, 3 to what power equals 81 is just a 4. Now, this change of base theorem tells me that I can make this equal to log of 81 over log of 3. Log of what's inside over log of the base, and that should give me the same value. Let's check it out. I've done it ahead of time on my calculator because remember I said you could do it with other bases as well, one of these. Notice that when I open up my calculator to see this log of 81 over log of 3, log of 81 over log of 3 gives me that 4 that we know the answer is. Also, natural log of 81 over natural log of 3 also gives me the 4. As well as if I did log base 64 of 81 over divided by log base 64 of 3, that also gives me the 4. So any base you change it to, we're just going to use the log, common log, and the natural log because those are the ones in our calculator. So be aware that some calculators can do these different bases, some can't. This change of base theorem works no matter what. So let's illustrate the change of base theorem on another problem. If I do this one, now this one was easy because we know what 3 to the 4th power is 81. We know 3 cubed is equal to 27. Well, 70 is somewhere between 3 and 4. It's not an easy number that pops out of the problem. So we're going to use our change of base theorem here in order to get that answer. So I'm going to make this log of 70 over log of 3. Let's do that on a calculator now. We'll clear these off. I'm going to do log of 70 and the parentheses divided by log of 3. And I get an answer of about approximately 3.867. 3.867 to 3 decimal places. Again, I'm having to round, but oftentimes you could include more of the decimal if you'd like to get more precision. But if you put 3 to this power, or more importantly, if you put 3 to that power, so 3 raised to that power of whatever that was in the answer to that, you're going to get that 70 out, okay? Now, if you've rounded it, it might give you something close to 70. Just be cautious about rounding. All right, let's do some more examples here. Let's solve this equation using this idea of changing the base. So first thing I'm going to do is I'm going to make this into convert it into a log. So I'm going to take and use my circle tool and say log base 13 of 23 is going to equal 4x plus 2. Now I can do this on my calculator if I'd like to, but to keep it exact, I'm going to just leave it in this form, and then I'll do the calculations at the end. Log base 13 of 23, we're going to subtract 2 equals 4x. Now I'm going to make this log base 13 of 23 minus 2 divided by 4 will give me the x. Now I'm going to use my change of base theorem to get that decimal. So what that would look like is if I were to do log of 23 divided by log of 13, that's changing the base, minus the 2, all over the 4 will give me my x. Let's go ahead and do that calculation on our calculator. So I'm going to have log of 23, put this is my numerator fraction, so log of 23 divided by log of 13, okay, and that parentheses. And now I'm going to subtract, remember I've got to subtract off the 2, and then end the numerator parentheses for that, and I'm going to divide then by the 4 that I have. And so I get an answer here so when I look at my answer here, I'm going to get an answer negative about 0.194. So x is going to be approximately negative 0.194 if I were to round that. Okay, so notice my answer there is gives me let's just redo that. So now I'm going to take this problem here, which has 13 to a power equal to 23, and I'm going to go ahead and convert it into a logarithm and then use my change of base theorem. So if I convert it into a log, I'm going to go with log base 13 of 23 is equal to 4x plus 2. Now let's convert this into log of 23 over log of 13, and let's subtract that 2 from both sides, equals the 4x. Okay, now I'm going to do this on my calculator and leave it on the calculator screen. So if I do that, clear this off, I'm going to go log of 23, and the parentheses there, divided by log of 13, and then I'm going to subtract 2. So I get this negative 0.775, etc. So I'm going to leave that on my screen for a moment. My next step then is to take this and divide by 4. So what I'm going to have here is this complex problem here, log of 23 over log of 13 minus 2, and that's all going to be divided by 4 is what x equals. Now all I have to do here is take what I've got there, that was the numerator, and divide it by 4 to get my answer. And so I get about negative 0.194. So x is approximately negative 0.194 for my answer. So the idea here is to go ahead and change it to a log, use your change of base in order to get the answer. Now, what I want to do to finish this is to prove to you the change of base theorem. We want to prove that this is equal to this. The way I'm going to start this proof is I'm going to start with an exponential. I'm going to start with having log base b of n. I'm going to start with this side, and I'm going to get it equal to finish with that side. So what I do when I want to simplify these, remember, is I'll set it equal to x. So I want to get what x is equal to. I'm going to change it into an exponential here. So I'm going to go ahead and do my circle tour and get b to the x is equal to n. Okay, now what I want to do, in order to get that x out of the exponent, I'm going to take the log of both sides. So log of b to the x is equal to log of n. Now I bring that x in front using my rules of logarithms, which means I can bring the exponent in front of the logarithm using the properties that we've discussed. And now I can divide by log of b, and so I get common log n over common log of b is equal to my x. So I've shown that that's what we get as a result if we work with changing this side into that side. So this change of base theorem is really kind of revolutionary. It allows us to not have to worry about other bases like base 2, base 105. If we had base pi, for instance, we can change all those bases to the very common bases of the common log of base 10 or the natural log of base e, use those and use our calculators in order to do our calculations.